Today we're going to be working on Module 3, Lesson 3, and today we're actually going to start adding two different types of fractions together. So you may notice when you're taking a look at this problem that we're going to be starting to add that I have 1/2 plus 1/4, but you'll probably notice that my denominators are different. And whenever I'm adding or subtracting fractions, my denominators have to be exactly the same or I can't add them. So today we're going to be talking about how we can get equivalent fractions from a problem and then use those equivalent fractions to correctly add up these two fractions together. And we're going to be using the models that we have been using from Lesson 1 to help us out with this. So what I have right here is I have 1/2 in a model, so I split a box in half and shaded in one part to show 1 out of 2. And now over here I have 1/4 shown in a model, except I cut this box horizontally instead. So I cut the first fraction vertically and I cut the second fraction horizontally to show it. And I shaded this one in at the bottom. Now, what I need to do is I need to create equivalent fractions. Remember that equivalent fractions are fractions that equal the same thing, they just look a little bit different. So to do that, I am going to use my models to help me out with this. And what I mean by that is that since this model is split into fourths, I also want this model split into fourths horizontally as well. So I'm going to draw lines straight across like this and split this model into fourths. And what I just created by splitting this model into fourths is an equivalent fraction because I still just have half shaded in. But now what happened is I created a new fraction. So I have 1, 2, 3, 4 parts shaded in out of 1, 2, 3, 4, 5, 6, 7, 8 total parts. So this fraction, or this model, now equals 4/8. But I also need to change this model to also have a denominator of 8 as well, because I can't yet add 4/8 plus 1/4 because my denominators still do not match. So how I'm going to show this is just like how I cut this model into fourths, I'm going to split this one in half because this model was split in half, so I'm going to split this model in half. Great, I'm going to split this model in half right here, and what that leaves me with is 2 shaded in parts out of 8 total parts as well. So what I have is I have common denominators now. They both equal the same thing. Because they both equal the same thing, I can now add them together. Remember, when we are adding fractions, we're not just adding the denominators, so I don't add those. So I know that my denominator is going to be 8. My numerator, though, the number on top of my fraction, is going to change. That's going to be 4 plus 2, and that equals 6. I can also use my model to help me figure out what my numerator is going to be, because I can count the total amount of shaded spots between my two models. So I have 1, 2, 3, 4, 5, 6, and that gives me 6/8. So that is how we complete our first problem. So on your notes, please make sure you were cutting up your models, and then I want you to show this work as well, because you are going to have to do both of these things when you do your problem set today. So I'm going to erase this, and we're going to move on to the next problem. And for this next problem, we have 1/3 plus 1/2. So I'm going to draw a model to show this. You have the model already on your notes, but I'll show you how we draw these models. So usually we want to draw a model for both of the fractions. So I'm going to start with my third. And my first fraction, I always want to cut that first one vertically. So I'm going to cut this one vertically up and down. And since it's 1/3, I'm going to shade in one part. And you'll probably remember how to do this from Lesson 1. Now my next fraction is 1/2, except when I draw my second model, I always want to cut it horizontally. and then I'll shade in one part. And the reason why I do it like this, where I cut one vertically and one horizontally, is because that kind of helps me create those equivalent fractions later on when I draw my models. So what I need to do is I need to make both of these models basically look exactly the same. So this model is cut in half. So I need to cut this model in half. This model is cut vertically into thirds, so I need to cut this model vertically into thirds so that they look exactly the same. To do that, I'll cut this model in half, just like how this model is cut in half. And again, this model is cut into thirds, so I'll cut this model into thirds. So now I have equivalent fractions that I just made, so I'm going to write down what these fractions now are and check that they do have common denominators and that I can add them. So this one, I now have 2 parts shaded in out of 1, 2, 3, 4, 5, 6 shaded parts. So I have 2, 6. Plus, I now have 1, 2, 3 parts shaded out of 1, 2, 3, 4, 5, 6 total parts. My denominator is the same, so I can add my fractions. Remember, your denominator does not change when you add fractions, so make sure you're not doing 6 plus 6 because that would be incorrect. It's just going to be 6. But I do add up my numerator. So I have 2 plus 3, and 2 plus 3 is 5, and I can always check my work as well by counting in my models. I have 1, 2, 3, 4, 5 parts shaded in, and that gives me a final answer of 5, 6. So far, not too bad, but it does get a little bit trickier for this next problem because I am going to be working with fractions that have more parts shaded in. So for this one, we have 2 thirds now plus 1 fourth. So again, just like last time, I draw a model for each fraction. So we draw a model for each fraction. This first model, I'm going to split it vertically into thirds because that is my denominator. So I split it vertically into thirds. And then I take a look at my numerator. My numerator is 2, and what that means is that I need to shade in 2 parts out of the 3 parts. And then over here I have 1 fourth. So since my denominator is 4, I need to split this model into fourths. Except remember, I do this horizontally. So I'll split this into fourths. And then starting from the bottom, I am going to start shading it in. So I look at my numerator. My numerator is only 1, so I'm only going to shade in 1 part. So now I'm showing you 2 thirds and 1 fourth. But remember, I want both of these models to look exactly the same or be cut up exactly the same, even if they have different amounts shaded in. So to do that, I take a look at this model and I see, well, this model was cut into fourths horizontally. So this model needs to be cut into fourths horizontally. This model was cut into thirds vertically, so then this model needs to be cut into thirds vertically. So when you're looking at these models and you're trying to figure out how to make them equivalent or have the same common denominator, what you need to think about is, how is this one cut up? How can I cut up this one the same? How is this one cut up? How can I cut up this one the same? So that they both have the same parts. So 5th grade, this one was cut into fourths. So I'll cut this one into fourths, and then this one will cut into thirds vertically, so I'll cut this one into thirds vertically as well. So now we have equal parts grouped up on both sides. So now I need to see what my new equivalent fraction is. So I have 1, 2, 3, 4, 5, 6, 7, 8 parts shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 8 out of 12 parts shaded in, or 8 twelfths. And then over here, I have 1, 2, 3 parts shaded in out of 12 parts as well. So now that I have these common denominators, I can now add all of this up. So I'm left with 8 plus 3, which is 11. And remember, my denominator does not change it stays the same, so I'm left with 11/12. And that is my final answer for this problem. 5th grade, I want you to flip over to the back side of this page, and we're going to work on one more problem together. And this one's going to be our trickiest problem of the lesson because now I have to add two fractions that have multiple parts shaded in, not just that one part that we've been used to. So we have to draw a model for 2/5, and then I have to draw a model for 2/3. So for 2/5, remember I always start vertically for this first fraction. I have 1, 2, 3, and 4, and then I'll shade in two parts because I always want to look at my numerator. That tells me how much I have to shade in. So I shade in 1 and 2. And then over here, I need to split this one into thirds because that is my denominator. So I split it into thirds, like so. And then starting from the bottom, I'm going to shade in how many parts I have. So I have 2 parts that I need to shade in because my numerator is 2. So I shaded my 2 parts like this. And now I want both of my models to look the same. So even though they are different fractions, I want them to look the same. So since this one is cut up into thirds horizontally, then I need to cut this one up into thirds horizontally. This one was cut up into fifths vertically, so this one needs to be cut up into fifths vertically. So I'll cut up both of these models. And now we have models that look the same. The only thing that's different is the amount that is actually shaded in on both sides. So I'm going to write my new equivalent fractions. 1, 2, 3, 4, 5, 6. So I have 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 6/15 plus 1, 2, 3, 4, 5, 6, 7, 8. Plus 8/15. I have common denominators now, so I can add up my numerators. Remember, my denominator is not going to change. It's going to stay as 15. And now I add up my numerator, 6 plus 8. 6 plus 8 is 14. And remember, if you have any difficulty adding up these numbers, then you can just take a look at your model. So I can add up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So that is another way that we can do this. So my final answer is 14/15. So 5th grade, for your very last problem, this is your you try problem, you're going to be adding 2/7 plus 2/3. I have the models already drawn out for you, so you just need to correctly cut them up so that they look exactly the same, and then write your equivalent fractions, and then add those up because they should have common denominators. If for whatever reason you draw your models and your models do not have common denominators, you should go back to redrawing your models because you should always be getting common denominators after you cut up your figures. So be on the lookout for that, and good luck today, 5th grades.